We're also the leaders in advanced packaging technology. Our investments and innovation in packaging have been a multi-year, multi-technology journey. In 2015, AMD introduced high bandwidth memory, or HBM, and silicon interposer technology to the GPU market, which led the industry for memory bandwidth in a small form factor. We then set a new performance trajectory for compute in the data center and PC markets in 2017 when we introduced high-volume multi-chip module packaging. And in 2019, we introduced chiplets using different process nodes for the CPU cores and the I/O in the same package, which enabled significantly higher performance and capabilities. Now today, I'd like to show you the next big step forward. We've worked closely over the last few years with TSMC on their 3D fabric technology to combine chiplet packaging with die stacking to create a 3D chiplet architecture for future high-performance computing products. Now let me show you a little bit about how our 3D chip stacking technology works. The first application of this technology will be to enable a 3D vertical cache. In this prototype, we're taking our leadership Ryzen 5000 series processor and stacking a 64 megabyte 7 nanometer SRAM directly on top of each core complex, effectively tripling the amount of high-speed L3 cache feeding our Zen 3 cores. The 3D cache is bonded directly to the Zen 3 CCD with through-silicon vias passing signals and power between the stacked chips, supporting more than 2 terabytes per second of bandwidth. Through the manufacturing process, we thin the 3D cache die and add structural silicon to create a seamless surface for the combined chip. The finished 3D stacked version of the CPU actually looks exactly the same as the current Ryzen 5000 processors. So now let me show you what that looks like. So this is a prototype Ryzen 5900X processor with the 3D chiplet technology. We've actually removed the lid from this package and exposed the left CCD so you can see one of the 6 millimeter by 6 millimeter square SRAMs hybrid bonded to the CCD. In an actual device, an individual SRAM is bonded to each CCD, so you get 96 megabytes of cache per CCD, or 192 megabytes total for a 12 or 16 core Ryzen processor in a single package. So now let me give you a little bit more detail about the technology itself. We're using a hybrid bond approach with through-silicon vias that provides over 200 times the interconnect density of 2D chiplets and more than 15 times the density compared to other 3D stacking solutions. This actually enables a much more efficient and denser integration of our IP. The die-to-die interface is using a direct copper-to-copper bond with no solder bumps of any kind. This approach dramatically improves the thermals, the transistor density, and the interconnect pitch, and is only 1/3 the energy per signal of micro-bump 3D approaches. All of these things make this truly the most advanced and flexible active-on-active silicon stacking technology in the world. Now, let's see this in action. Larger caches are important in many workloads, but PC gaming is a workload all of us know well. Let's take a look at a demo using Gears 5. On the left side is a Ryzen 9 5900X, which is today's fastest gaming CPU. On the right side is a 3D chiplet prototype based on the 5900X with the new 3D V-cache technology. Both CPUs have the same core count and thread count and are fixed at 4 gigahertz clock speed. Frankly, the gaming performance of both processors is extremely good, but the 3D chiplet prototype improves performance by 12% on average. This is actually just phenomenal, and the impact of 3D chiplets on a real workload. In fact, when you look across many of today's games, they have intense demands for the PC memory subsystem, and they get much faster when you bring lots of memory close to the processor. If you look across a number of popular game titles with the V-cache technology, we're seeing an average improvement of 15% at 1080p. Now just think about that. That's 15%, which is an entire architectural generation's worth of gaming performance just from the 3D V-cache technology. I'm excited we got to give you a preview of our 3D chiplet technology today. We've actually made great progress on the overall development of this technology, and we'll be ready to start production on our highest end products with 3D chiplets by the end of this year.